Hello, I guess I'm audible. Welcome to the session. Uh, I'll just wait for a couple more minutes for others to join and then we'll start with the session. Okay. Thank you for joining. Please stay online.
Yep.
Hello. Okay. So let's start with the session then. Good evening. I am Somnath Hazra, a second year PhD student, and this is week 12 of operating system fundamentals course from offered from NPTEL, that is CS100, and this is an NPTEL live session where we'll be discussing a few questions and related to the week, related to whatever has been taught in the throughout the week. So this is the last week of the course, and today we'll be looking at a few questions related to file system. Okay, so let's go ahead. So I guess I'm audible and you can view the questions, I think. So if you have any doubt, you can use the chat box, and for replying also, you can use the chat box. Okay. So anyway, let's move to the first question. So if you want to set the following protection for a file that is given by this table, so if you want to set this protection, what should be the command? I guess you are aware of the change mod command, that is a chmod that is written here. So let us suppose that the name of the file is file underscore name, whatever that is. So which among the following options do you think is correct in order to set these permissions for the file? Anybody would like to contribute? Okay, so what change mod is does is it is used to change the permissions related to a file. So there are primarily three stages of permissions that you need to set. That is the owner, that is for the owner of the file, for the group that to which the owner. Okay, okay, no problem. So anyway, we'll discuss the answers also. So if you are having any doubt, you will get your doubts cleared hopefully through the answers through the session. Okay. So anyway, the group belongs. Yeah, the you need to set the permissions for the group that is to which the owner belongs, and to the general public as such, to anybody who is accessing the system. Okay, so these are the three stages of permission that you need to set for each file, and by default they are particularly set. If you have used any Linux or Unix systems, you may have used these types of commands. So here in the example, what it is written is R stands for read, W stands for write, and X stands for execute. There are certain files which you need to execute, right? For example, an exe file in a Windows system, those files execute in the system. So those are the permissions that you need to give to the file. Okay, that whether you can read into a file, whether you can write to a file, and whether you can execute. Okay, so accordingly, uh, as you can see, there are 3-bit numbers that are generated. So what these 3-bit numbers represent are uh, an equivalent decimal number. So for example, 111, if you are familiar with the binary decimal conversion, interconversion, this represents the number 7. Okay, so 101, this represents the number 5. 100, this represents the number 4. Okay, so what you need to use as a command is uh, with the ch mod, along with these decimal indications, you need to set the permissions for various stages of the file. Okay, and then you need to specify the file name, of course. So in this case, the owner permissions comes first, then the group permission, and the public, and then after that the public permission. So what will be the numbers for this particular sequence? So since the owner has every right, that is to read, write, and execute, yes, it will be 754. So what will be the correct option then? So the correct option here will be option C. Okay. So this forms a 7, this is a 5, and this is a 4. Okay. Anyway, let's get to the next question. So which of the following directory organization links are used to point both files and subdirectories? General graph directory, acyclic graph directory, tree structure directory, or none of the above? Both files and subdirectories. So anyone would like to contribute? So even if you don't know, you can take a general guess also. That is okay. Tree structure, okay. Okay, acyclic graph directory. Okay, so let's get to the answer then. So what happens is, in a general graph directory, if you know about graphs, there may be cycles that are created. Okay, so if since we are using links to point at both files and subdirectories, and if a particular subdirectory has a reference to another file, that may create a cyclic kind of structure. So in order to break that kind of cyclic structure, you need an acyclic graph kind of directory. Okay, for that. Okay, and tree is a particular hierarchical structure which may not always be enforced, which may not always be required. So acyclic graph directory will do for our case. Anyway, let's get to the next question. So which of the following disk scheduling algorithm should not be picked for systems that place heavy load on the disk? Okay, so we are discussing this question for which of the following disk scheduling algorithm should not be picked for systems that place heavy load on the disk? Scan, C-scan, SSTF, or all of the above? Should not be picked. So even if you are unaware, you can take a guess also. No harm in that. Okay, okay. Anyone else? Okay, let's get to the answer then. So the answer is SSTF, shortest shift time first. That is the algorithm that should not be picked. So what SSTF does is that it picks up random sequence of numbers uh, so that it has so that there is minimum shift of the heads, right? The disk that is the read write head. So it has to pick a random sequence of numbers. So what that does is, so it can once go back and go forth repeated number of times. So what that creates is it places the heavy load on the disk, since it is not happening sequentially, that is, it is not reading everything at a single motion. So the read write head has to move back and forth multiple number of times for doing SSTF. Okay, although the overall time consumed that reduces, but there is a heavy load that is placed on the read write head and other mechanisms that are present on the secondary disk. Okay, so that places a heavy load on the disk, and thus uh, yeah, it should not be picked. Okay, for those systems. So anyway, let's get to the next question. So which of the following is not an example of secondary storage? So if you have uh, had attended one of my previous sessions, we had done it in the starting sessions, I think session 1 or 2 or something like that, that there was that disk hierarchy. So in that we had studied that which of the following does not belong to the secondary storage, primary storage. We had studied about all those groups. So yeah, I got one answer. Anyone else would like to contribute? Me. So these are just one word kind of answers. So what secondary storage means is that it is not placed in the system as a whole. Okay. So what primary storage means is that it is uh, kind of part of the system and part of the computation. Okay. Actually, I think this should be tertiary storage, not secondary storage. Sorry, there is a mistake in the question. So everything is not a part of secondary storage actually. Yeah, I think it should be uh, tertiary storage. Anyway, yeah, RAM is the answer for this question. So, yeah, RAM is a part of the primary storage and is an active part of each and every program execution. If you had if you remember from the previous sessions and whatever was taught in the class in the previous weeks. So, what happens is that it is a part of the active computation. So whenever there is a program executing in the CPU, in the processing unit, whenever there is a program processing, RAM takes an active part in that random access memory. Okay, so it is a part of the primary storage. Secondary storage belongs to hard disk drive and all those things. Tertiary storage is a class that takes in magnetic tapes, optical disks, and things like that. So optical discs, they are what they can be done is the after the storage is complete, so they can be detached from the system as a whole. So they need not be attached to the system at all. So that is why it is called tertiary storage. So anyway, let's get to the next question. So the time for the disk arm to move the heads of the to the cylinder containing the desired sector is called disk time, arm time, sector time, or seek time. Okay. So the time for the disk arm to move the heads to the cylinder containing the desired sector is called disk time, arm time, sector time, or seek time. Which among the following options do you think is correct? Uh, yeah, okay. I got one answer. Anyone else would like to contribute? So if you are facing any difficulty with seeing the questions or anything like that, you may please inform me in the chat box. I'll try to resolve it. Okay, I got two answers. Anyone else would like to contribute? We'll go through what all these means. Actually, some of them even don't even exist. Some of those terms. Anyway. Okay, so the answer to this question is yes, seek time. So anyway, we'll look at what all these times mean. So seek time actually means that the time, yes, that was asked in the question actually. So the seek time is the time taken for locating the disk arm to a specified track where the read-write request will be satisfied. So yeah, so that is what is done in the seek time. Rotational latency is after the read-write head is taken to that specific track. So that track has to be rotated to the appropriate sector so that the appropriate sector comes under the read-write head, right? So that is what is called the rotational latency. So after that, the transfer time is simple. That is the time you need to time taken for the transfer of the data between the uh, secondary storage and the computer. And the disk access time is actually the sum of all these three. That is the rotational latency, seek time, and the transfer time. Because all these come under the total time that is taken for accessing the disk, right? So the sum of all these three is known as the disk access time. Okay. So anyway, let's get to the next question. So in sequential access method, how the file pointer is affected by read next or the write next command. Excuse me. So even if you don't have any idea about what sequential access method is, so you can think about it is you can take quite the literal meaning of it. Like sequentially, it is accessed. The files that are taken into consideration, they are accessed sequentially. Options are quite simple. So if you even if you don't know, you can take a wild guess. Okay, I got one answer. Anyone else would like to contribute? Okay, I got two answers. So what happens in sequential method is you access the data points sequentially, one by one, one after the another, one after the other. Okay, and what is the other option is direct memory access, where the complete uh, file system is separated into fixed size blocks, much like what happened in the case of pages and the frames. So the whole RAM was primary memory, sorry, was broken up into fixed size blocks. So similar things happens in direct memory access in case of this also, secondary storage. So the complete uh, storage is broken up into fixed size blocks, so you can directly access a particular location of the file, much like what happens in array. So since you know what is the size of the array, you can automatically access a particular index of the array directly without going through all the headers, all the before elements, right? So unlike what happens in linked list. So even though the concept is different here, but yeah, uh, you can get an idea about that. So anyway, I diverge again from the topic. So the answer to this question is A. So Read next. So it reads whatever is next after the pointer, after the read pointer, and then moves on to the next value. Similarly, write next. It writes to the end of the file after whatever is whatever how much has been written. Up till after that, it starts writing whatever is to be whatever is needed to be written, and then it moves on to the next value. Okay, so yeah, that is what happens. So anyway, let's get to the next question. So which of the following disk scheduling algorithm searches in only one direction and the arm goes only as far as the last request before reversing its direction? So your keywords are searches in only one direction and the arm goes only as far as the last request. So those are the important things that you need to consider. Your options are look, clook, scan, and cscan. So, would anybody like to contribute? Okay. Okay. Yes. Only in one direction. Since it is given, it searches only in one direction. So there should be a C. So either it is clook or cscan, one among these. Okay. And the other thing that is written is only as far as the last request before reversing its direction. So what happens in scan is, so it goes up till the end of the disk, right? Even if it does not need to, it still goes up to the end of the disk and then it reverses direction. But how is look an advantage over scan? It only goes up to the end of up to the last request. It does not go up to the end of the disk. So the answer in this case therefore is C look. Okay. So yeah, in this way actually look is more practical, and look and SSTF are the more practical options for this scheduling actually. But SSTF, as was said, it may suffer there may be a case of latency actually in SSTF, because if there is a request for a particular sector which is very far away from what is being currently accessed, then it may take a whole lot of time to access that particular sector, and thus it may suffer from starvation, and that is a problem in SSTF. Okay, so that is the shortest shift time first algorithm. So that is a problem, but yeah, look and SSTF are the practical algorithms. So anyway, let's move to the next question. So which algorithm of disk scheduling selects the request with the least seek time from the current head positions? So this is very simple. So we just discussed. No. So this is the optimal algorithm, right? It will select the request with the least seek time. We just discussed a few questions before. If you expand the acronyms of these algorithms, you'll get the answer. SSTF stands for shortest shift time first. FCFS is first come first serve. Scan and look. Okay. So yeah, anyone else would like to contribute? Just give me a moment. Okay, so yes, SSTF is the answer because as the name suggests, shortest shift time first, it will next select the request with the least seek time. Okay, so let's move on to the next question. This is if you haven't studied, gone through the theory yet, so this may be a bit difficult. So RAID level 1 refers to disk array with striping, disk mirroring, both of the above or none of the above. So what happens is for maintaining security of the disks, since these are all secondary storage devices, so they may crash. Okay, so what happens is that for maintaining security, there there are various RAID levels. Okay, so what happens is either you can create copies of the data, uh, like two copies of the same data at separate disks, or what you can do is you can distribute the data bit among various levels of a single disk. So if you know about the hard disk structure, there are various uh, uh, yeah, there are I guess the whole complete folder is shared. I had actually shared the complete folder with NPTEL, so we do share it regularly. But anyway, I will just share it. Just give me a moment. I'll give you the link. Just give me a Okay, in this drive folder, Google Drive folder, you will have the PDFs of all the previous sessions. So today's session, I will be uploading the PDF after I am done with this current session, and then you can find it in the same link. Okay, no problem. Uh, Anyway, let's continue with the question. So, what I was saying is that is the first thing that I was saying, that there are multiple copies that are created of the same data, that is known as disk mirroring. Okay, and what happens is in disk arrays with striping, so the is a byte of data is distributed among several disks. Okay, so that creates the security. It is not sequentially stored in a single disk. Among multiple disks, a single byte of data is shared and is actually distributed, not shared, distributed. So that is known as striping. So anyway, let's get to the answer. Okay, so RAID level 1 refers to disk mirroring. So these are various security levels. So yeah, disk level 1 refers to mirroring. Okay. Let's get to the next question. So this is a numerical. So it is has 200 cylinders, 0 to 99. If the initial position of the read-write head is at cylinder 39, calculate the total head movement following SSTF policy. For the read sequence, that is given as 25, 112, 84, 188, 2, and 154. So you have to follow the SSTF policy. So you have to follow the SSTF policy. Okay. Okay, don't don't just take a wild guess. So yeah, uh, that is the least number doesn't necessarily mean that that is the answer. So currently, the read-write head is at 39. So these are the requests. Now you have to calculate what are the how the request will be satisfied. Okay, so this is the sequence of requests. The simplest would have been FCFS. So in FCFS, after 39, it would have gone to 25, then 112 in this sequence. But it is shortest shift time first. So yeah, I'll give you a few moments to calculate the answer. Give you 5 minutes. I'll also try to parallelly solve the question. Please try to solve the question. I'm also parallelly trying to get the answer. So if you have an answer, give you another 2 minutes. Okay, I have one answer. Anyone else would like to contribute? Okay, let's get to the answer then. So yes, 223 is correct. So this will be the order in which the disks will be accessed. Okay, so in which the read-write head will move and the request sequence will be satisfied. So first it will go to first it is in 39, then it will go to 25 because that is the closest to 39, and then 2, and then with the same logic the rest. Okay, so how do you count the jumps? The previous position minus the next position mod of that. Okay, so that is how you will get to 223. So if you haven't solved, you can take a note of it. Now, 189 was also not correct. 223 is the correct answer. So if you sum all this, if you do the summation of all these, you'll get to 223. Okay. Okay. Is anybody getting anything, any different answer or has any doubt? You can use the chat box. Let's get to the next question otherwise. So this is another numerical. So actually the same numerical. So instead of the other policy, instead of the SSTF policy, here you have to look, here you have to use CLOOK. Okay, so that is the only difference. The rest of the question stays the same. It is 200 cylinders, 0 to 199 is the are the positions. So if the initial are the indices. So if the initial position of the read-write head is at cylinder 39, calculate the total head movement following the C-loop policy for the read-write sequence 25, 112, 84, 188, 2 and 154. So these are your options: 358, 368, 278 and 288. So anyone would like to contribute? So this follows the C-loop policy. Okay. It will go towards the increasing sequence and then it will jump down to 0, not to 0. Since we are using C-loop, in C-scan it would have jumped down to 0 after going to 199. Here it will jump to 2 after going to 188. Anyone with the answer? We'll wait for a couple of minutes more before going to the answer. In C loop, you do not go to the end of the file, disk, and neither you jump to the beginning. Only the cylinders that need to be accessed, that last cylinder that needs to be accessed, that is the limit. Okay. In C scan, you jump to the end and then go to the beginning. So that is much like the elevator. No, that is not like the elevator. That is much like the escalator actually, the C scan policy. So it goes only in one direction, and whether you have to get down in between, it doesn't care. It will take you to its starting to its destination. You cannot get down in between, right? It will, and neither it scans in the reverse direction. The scan is like the elevator. This is like the escalator, C scan. Anyway, we diverge from the question. Okay, I have one answer. Anyone else would like to contribute? Anyway, let's get to the answer now. So yeah, 358 is the answer. So this is the order in which it will be accessed. So the disks will be accessed. Sorry, the cylinders will be accessed, and yeah, you can accordingly calculate the answer. Yeah, 358 is the answer. Anyway, let's get to the next question. So, which of the following is correct about linked allocation? Each block contains a pointer to the next block. Locating a block can take any number of IOs and disk seeks. Reliability issue arises when one of the pointers gets corrupted, or all of the above. Linked allocation. So if you know about linked list, even if you do not know about linked allocation, okay, I have one answer. So even if you do not know about linked allocation, so you can think it in terms of a linked list. So what would have happened? So think of a linked list kind of a structure, but in a disk, okay, with many cylinders. So what will happen? I got one answer. Anyone else would like to contribute? Okay, I got two answers. Anyone else would like to contribute? So in linked allocation, yes, as I said, you can think of it as a linked list. So each block pointer contains each block contains a pointer, needs to contain a pointer to the next block. And since it is a linked list, you cannot directly access a particular block. You have to go through many disk seeks and input outputs in order to go through a sequence of pointers in order to get to the block that you actually need. Okay, so and that is what happens in linked allocation also. A similar thing happens in linked list also. So that is why the sentence B is also true. And if one of the pointers gets damaged in between or gets corrupted in between, so so the whole link is destroyed, right? So after that pointer you cannot access the whole sequence of data that is present after. So that creates a reliability issue when one of the pointers gets corrupted. So see, sentence C is also correct, right? So that is why all is correct, all are correct. All of the above is the correct answer. Yeah. Okay, so that brings us to the end of the session. Thank you all for joining. So this was the last session. So yeah, thank you all. So as usual, you will get the PDF links of all the previous sessions and this session also in the Drive folder. So that I had shared, and hopefully the Drive folder is shared in the NPTEL course web page. So I was informed likewise. If you are having any problems, you can still ask me here. Otherwise, yeah, that's it from the session. Thank you for joining again. So, yeah, you can drop off now. Thank you.